So today I am going to talk about recursion relations and three-body phase space. So let us recall general phase space relation. General phase space relation means it is Rn, it is Pe, it's equal to integral product I varies from 1 to n dqpi to ei delta cube summation I varies from 1 to n pi minus p delta summation ei minus e. And so in case of center of mass frame, this p is equal to 0. So if I put it like this, then Rn0e, it can be written like this: pi I varies from n 1 to n, it is dq pi upon 2 ei delta cube summation I varies from 1 to n pi minus p delta ei minus e, and its summation I varies from 1 to n, but p will be 0. So if it will be 0, then I can write down it like this, right? So let us write down it in different way. This can be written as Rn0e. It can be written like this: it is dq pn over 2en, and then again integral pi I varies from 1 to n minus 1, because I have taken it outside, so it is dq dq pi 2ei, and it's a delta q summation I varies from 1 to n minus 1 into pi minus pn. It can be written like this into delta ei, not ei, but first of all let us take summation I varies from 1 to n minus 1 ei minus e minus en. It can be written collectively like this. So therefore this R0e and this whole term, it can be expressed in this way: it is R n minus 1 minus pn e minus en, right? So I have to take it like this. So therefore Rn0e, it can be written as integral of dq pn over 2en Rn minus 1 minus pn e minus en. It can be written like this. Now R0e, it can also be written like this in the short notation: minus Rn 0 epsilon, right? It can be written like this. So let us call it as equation number 1. Now here Rn minus 1 0 epsilon, this is epsilon, this can be written as so it's Rn minus 1 minus Pn E minus En, where this epsilon can be written as this E minus En, its square minus Pn, its whole square, whole under the root. So it can be written as E minus En whole square minus Pn square under the root. So therefore epsilon square can be written as it is the value of this, and epsilon square can be written as E minus En whole square minus Pn square. So let me simplify it. So it simplifies to E square plus En square minus 2En minus Pn square, and these two terms can be collectively written as Mn square. So therefore epsilon square can be written as E square plus Mn square minus 2En. So let us call it as equation number 3. So let us now use recursion relation given by equation number 1 to derive 3-body phase space. So R30E means 3-body phase space relation can be written as dqp3 over 2e3, its integral R20 epsilon and what is it? This is basically 2-body. It is basically 2-body. This corresponds to 2-body phase space, right? So if I put its value from the earlier lecture, I can write down it as it is integral dqp3 2e3, it is pi p prime over e prime, and e prime is basically written here as epsilon. So it can be written as dqp3 2e3 pi p prime over epsilon, and here p prime is momentum. It is momentum of each particle. It is momentum of each particle in 2-body system, and epsilon can be written as E minus E3 whole square minus P3 square. This is from the equation number 3, and momentum P prime can be written as epsilon square minus m1 plus m2 whole square under the root this is from the two body phase diagram, phase space integral. So it is m1 minus m2 whole square as we have derived for that. So it is like this. So therefore this R3 0E, it can be written as dq p3 upon 2e3 pi over epsilon square minus m1 plus m2 whole square under the root, and it is epsilon square minus m1 minus m2 whole square under the root divided by 2 epsilon, and integral will also be there. And as discussed earlier lecture, that dq p3 can be written as 4 pi p3 square dp3. It can be written like this. If I put its value here, then this is R30E. It can be written as 4 pi p3 square dp3 over 2e3 pi, and integral will be there, and it is epsilon square minus m1 plus m2 square under the root, epsilon square minus m1 minus m2 whole square under the root whole divided by 2 epsilon square. But as we know that this epsilon square is equal to, as we have written in the equation number 2, that epsilon square is equal to e square plus m3 square minus 2e3. So if I put its value, this is from equation 3. So if I put this value here in this equation, then what I am getting, that this R30E, it is equal to 4 pi p3 square dp3 whole upon 2e3 integral pi. So we can write it like this. It is 4 pi square, and here it is e square plus m3 square 2e3 minus m1 minus m2 whole square. It's under the root, and another term will be e square plus m3 square minus 2e3 minus m1 plus m2 whole square. It's under the root divided by 2 epsilon square. So that means that this 2 will goes to here. So I can write down it as 4 e, and epsilon square, its value will be e square plus m3 minus 2e e3, right? So this is the required expression. This is the required expression for phase space. So here E is equal to m3 square plus p3 square. I am using this result directly, right? And m1 plus m2 square plus p3 square max under the root, and p3 minimum is equal to 0. These are the things which we have to keep in mind, but I am using these results directly. Also p3 max, it can be written as e square minus m1 plus m2 minus m3 whole square under the root, and it is e square minus m1 plus m2 plus m3 whole under the root and whole divided by 2e. So this expression is similar as we have derived for P2. It is in the similar manner which we have derived. So this is the required derivation which we have derived here. So this is the required phase space for the three body diagram. So that's all for this lecture.